All right, let's look at the next couple of questions here. These both deal with graphing and finding the areas under those curves. And so we've got a couple of somewhat complicated pieces here. The first guy, question 4, wants us to find the area of in the first quadrant bounded by the line y equals x over 8, which is in blue. So this is y equals x over 8. The line x equals 3 is in red, so that's this guy right here. And the line 1 over x squared. Y equals 1 over x squared is right here. So basically what's going on is we've got two different things happening, and it all occurs at 2. Okay? At 2, we break our equation up into two different pieces. We've got this first piece right here, which is a triangular shape, which some of you may see. And so we need to find the area of this triangle. The other shape that we're really interested in then is this one right in here. So these are the two shapes that we need to determine the areas of. Well, there's no bottom equation here. The bottom equation is the line, is the x-axis line. So what we're going to do is we're going to have two integrals that we're going to add up, and they're really simple integrals. Okay, so we're going to go from 0 to 2 of the top equation, okay, which is going to be this first integral right here, 8 over 3. Not 8 over 3, x over 8. Plus the second integral, which is going to go from 2 to 3 of the second equation now, which is 1 over x squared. Okay, this needs to be x over 8. And all we need to do is add these two guys up. Once we add these two guys up, we'll find the yellow area and the blue area, and that'll give us the total area for this curve. So when I did that and punched it into my calculator, I got 0.41667. If you do this, you could also do this and find an exact answer. And the exact answer is going to be 5 over 12. So this is actually not too difficult of a problem to do that with because it integrates pretty nice. On the bottom, we've got this really wacky curve. Cosine pi square root of 2x over 3 equals 1 minus x squared. So this is really hard, and we had to see the whole curve because there's 2 points of intersection. There's a point of intersection right here and a point of intersection right here. This is a straight up top minus bottom situation, which means that we're going to integrate from the x-axis, which is that first point. And what I did that you can't see here is I went ahead and found the point of intersection, so use your calculator to help you do that. And where these two graphs cross is 0.7071. Okay? And now I just do the top equation minus the bottom. Well, in this case, the top equation is the 1 minus x squared equation. So I would simply have 1 minus x squared minus the bottom equation, which is that cosine one. Cosine of pi, let's see here, help if I could write. Pi times the square root of 2 times x over 3 dx. And this is a little bit more complicated. The actual integration of this guy is not too bad. You'll have a u substitution with cosine. So if you're trying to find an exact answer, that's what you'll need to do there. Finding the point of intersection can be really tricky, okay? And so for me, and with my classes, we just put it into our calculator and solved it out. If you are in another class where you have to show all your work, then all you would do is you would set cosine of pi times square root of 2 over x times x over 3. Just set that equal to 1 minus x squared. Solve it for x, and you'll be able to determine right where that's point of intersection is happening. So I punched it into my calculator, and I end up with it's a very small space. Let me see if I can highlight it for you. It's a very small space, and you can see a little bit of it just right here before it blends back in again. Okay, and it's very tiny. It's not very big at all. And so when you do this and punch it in, you get a very small answer, which is going to be 0.008966. units squared. You can also get an exact answer for this. So for those of you going for an exact answer, this is where you're headed. Okay, both of these guys would be in units squared. So I forgot to put my units squared up here. So this would be units squared as well. That needs to be 3 over 6, and that needs to be a 2 pi. All right, there you go. So there's the next two questions, finding areas under curves.